Alright, so today what I want you to do, the very first thing we're going to do is we're going to be doing a bunch of this sort of thing. Okay, so we're going to calculate 100 samples of size 50 from a single dice roll. So to do that, it's like we did yesterday, 1, 2, 3, 4, 5, 6, of course, equals, don't screw this up please, I'm telling you how to do it right now. Drag that down, Q, add-ons, XLMiner toolpack, start, random number generation, bam. We want 100 samples. We want 50 in each one. Did I do that backwards? Nope, that's what I wanted. Excellent. Good for me. We want a discrete distribution. Highlight your data first. Click in here. Okay. And then, of course, it's going to do that. And just put our data. Let's start it like an H1 or something. Okay. Bam. And here we go. Okay, so what we're going to do is the following. Every single time, you're going to be doing the same thing. If this gets around to finishing, it'd sure be nice. And come on, Betsy. You can do it. Come on, Betsy. Come on, you can do it. Come on. Come on. Wake me up when it's over, okay? Goodness sakes. Literally, somebody is at Google headquarters rolling the dice for me right now, apparently. 50 times 100, 5,000 times. It's going to take a while to roll those dice. Come on. God. Give it to me. Oh. They're all done. It would be helpful, Jay, if you'd keep track of, you said 50 in each one. Thank you for those of you that are laughing at me. I appreciate that. It hurts my feelings. So A1 colon A50. What just happened there? What just happened? Equals A1 average. What? What? Oh, phooey poop. Equals average. Let's go click and drag the data, apparently. Oh! I did A1. What a tool. Should have done H1. It's late at night, friends. Well, it's not really that late. It just feels late. Okay? It just feels late. Is that all of them? Apparently that's all of them. Voila. Copy that data. Cute. And then I would just prefer you just went to Excel and do this every time. So open up an Excel page. Remember to paste it like so. Copy it. Copy. Click it here. Transpose. Put in a title here. Average. Whatever you want to call it. Not important to me. Okay. And then insert pivot table. Boom. And bring your average here. And your average here. Make this say count. Right click around it. Group. Currently we're counting from there to there. Let's count it by 0.5s maybe. I don't know. Oh, that's too much, Mr. Groom. Should I have left it at 0.1? Maybe. I don't know. I just work here. That's too many, Mr. Groom. Yeah, somebody make it 0.2. Sure. Ooh. 1, 2, 3, 4, 5, 6, 7. That's not enough. I would like to have 5 bars on everything we do today. Nice. Alright. So grab it, insert, column, histogram, right click, format data series. Boom. Here we go. Alright, so today what you're going to be doing is you're going to be keeping track of these things. So you're going to copy this picture, copy it, You're going to paste this sucker into your into a Word document. Paste it as a picture, remember? Okay. This is going to be like 50 dice. Well, you can't change that because I made it a picture, but you could do this picture as this is for 50 dice roll, or from a sample of 100 samples of 50 rolls. Okay? And then you're going to do it again for different amounts. Okay? Now, here's something else I want to know. Going back to here, going back to here, my original data. What I'd like to do is this, equals average. I'd like to average this column of data that I found here. Are you with me? Now, in the case of rolling a dice, we already know what the data, we already know what it should be. Look at it. It's 3.4918. It should be 3.5. Geez, I am shocked. I'm not shocked, friends. Because we know that if you'd taken 1 times 1/6, well, what am I doing? We'd have it. It's over here in this page somewhere. Top of this page. Mr. Graham, couldn't we just do the standard deviations and the means this way? Couldn't we just go equals this feller times this feller? And then drag it down like so? And then find the sum of that? I feel like we could. And so here, friends, 3.5, that's our mean, yes? Now, recall that we also did a standard deviation, yes? So we did this fella squared times this dude. And we drug him down like so. Then we took the sum of that. Minus this feller square. And then we took the square root of that. 1.7. Okay? What I want you to focus on is, this is what the average is. Over here, the average of these averages, well, right there. But here's what I'm interested in, friends. Equals standard deviation. Not standard deviation. Equals square root. No, I want to do standard. You're right. I'm sorry. I did it wrong. The standard deviation of this sample. And what do you get? Well, you get 0.242. Okay? So what we're saying over here is this. In our pattern, we got that the mean was 3.49. Which is pretty close to what it's supposed to be. Standard deviation, 0.242 or something. Supposed to be 1.7. What is going on? Don't answer that yet, because eventually you're going to be able to figure that out. Back to Google. Alright? So back to Google. Let's go generate some more data. This time, let's keep that at 100, but this time let's go down to 1,000. Okay? And I'm going to go, I'm just going to overwrite my data. It should be fine, I think. Oh, Betsy. Well, better late than never. So it's finally done. Alright. So down at the bottom, of course. Oops. So here it is. So I'm going to have to add a row there. So it equals average. And of course that is H1 colon H1000. Bim. And take off a dragon. Copy those suckers. Let's go back over here to a new sheet. Click over here, let's paste. Let's copy those suckers. Let's click here, we'll do a little transpose action. Average, I don't care what you call it, it's not important to me. Click that sucker, whee! Down to here, no big deal. Copy, or not copy, what am I talking about? Insert pivot table. Boom. Average, average, click here, boom. No, not average, god dang it. Pay attention to yourself, Jay. There's too many averages going on. Count. There you go, up, Eb. Let's go to group. Notice how they're a lot tighter this time, friends. So I'm going to go by like 0.05s or something. Notice that's 6 bars. I need to count by something a little bigger than that. Perhaps I do 0.06. Let's see what happens. We'll sneak up on it. Holy buckets, yes, right there. Now, let's go to, what am I doing here? Insert, column graph, boom. Right click, data series. Squish that baby down, boom. Hey, look, it's kind of a symmetric dealio again. Copy that. Literally, copy that. Paste it. Okay, talk about what that looks like. Talk about the shape. It's fairly symmetric, whatever. Talk about how this was a 1,000 rolls. Okay, we know the mean should be 3.5. Wonder what it actually is. So let's come back over here to our last set of data we just had. I think it was this bunch here, wasn't it? Yes, I believe it was this last bunch. I think it's this last bunch we done. So equals average of A2 to A101. There's our average. Notice how it's 3.4999, whatever. It's pretty good. Equals standard deviation of the sample. Boom. Notice that again, it should have been 1.7. So this was 3.499. That's pretty good for the mean. Notice that it should have been 1.7, but this time it was 0.05. And the difference, friends, is the sample size. So what you're going to be spending some time today with is, first of all, we're going to be talking about different ones of these. So for the first ones, you're going to be doing just like rolling a dice. So it'll be discrete distribution. Then you're going to be selecting some binomials. Then you're going to be selecting a couple of Poissons and a couple of normals too. So we'll play it by ear. So that's the game. I was going to have you do a video lesson walkthrough. I decided I don't want to do that. So it'll be a Word document that I hand you, and then you will just basically do what I'm doing right here again. So yesterday we did this in class, so you should be able to come back and refer to what we're doing right here. Okay? Alrighty then.